All right, rate of change and slope, the beginning of chapter 4. Okay, so if we're going to start with key concept here of what is slope. Slope is the line, the slope of a line is the ratio of its rise to the run. In symbols, this would be the slope of m of two non-vertical points through any 2 points, x1, y1, x2, y2, can be as follows. The slope m is the change in y, which is y2 over minus y1, and x2 minus x1, otherwise known as rise over run, like that. That's the one we're used to seeing. All right, so here's just 4 different ways that it could be. A positive slope goes up from left to right, and a negative slope goes down from left to right. You could think of it like this. A positive slope, if I were a cross-country skier and I was skiing, if I go up the hill, I have to climb up the hill with those cross-country skis. Negative slope would be like gravity, so that guy would be able to slide straight down, so like a sled. So in that case, that would be a negative slope. A horizontal line would be a slope of 0. These are the two that usually confuse people the most. So slope of 0 would be across. Horizontal line, I think of it like sleeping. So if I'm asleep on my pillow, is a slope of 0 because I am at 0. Horizontal line, slope of 0. And an undefined slope would be a vertical line. This would be a falling man. Hopefully, we'll give him a parachute just so he doesn't die. Driving time. Use this table to find the rate of change, meaning, explain that meaning of the rate of change. So each time x, let's say I go 2 and then 76, 4, 152, looks like that's a consistent one. So every 2 hours, it increases by 76 miles. So to find that rate of change, I need to go change in y over change in x. So in this case, it's going to be the change in distance, so over change in time, the two that I'm using here. So I'm just going to take the first 2. So 152 is going to go over here, and 76 is going to go here. So I'm calling this my 2, and this is 1, so this would be x1, y1, and this is x2, y2. And that's how I'm putting those into that formula. So after I do that, that would come out to 76 over 2. I can reduce that to 38 over 1. So the rate of change means the car is actually driving at 38 miles an hour, rather than 76 miles an hour like most Californians. Yeah, right, they don't drive 76, they drive 80. Moving on. All right, use this table to figure it out. Go. All right, so we're going to have to find the rate of change. So minutes and cost of a cell phone. So if we call this one 1 and this one 2, this is going to be my x1, sorry, terrible x, and this will be my y1, x2, y2. We'll put that in the formula. y2 minus y1 over x2 minus x1, otherwise known as rise over run. So y2 is 2, and 1 minus 1 over x, 2 first. Yeah, 2 over 1, so x2. So x2 is 40 minus 20, so that's going to come out to 1 over 20. So that we can reduce down. It looks like they want us to go like a 0.5 over 1. So if I actually did that, so 1 divided by 20 in my calculator, that comes out to 0.05. That's what that would be decimal-wise. So I'm going to say the rate of change is rise over run. So my rise is over run. 0.5 over 1 would be 0.5 cents per minute. So I think it's going to be A. Right, the graph on the right shows the number of US passports used from 2000 to 2004. Find the rates of change. So they want us to get this rate of change and this rate of change. So I'm going to have 2 different options. Use the formula for slope. We're going to go a little quicker here because we got lots of slides. So we're going to change in quantity over change in time. Quantity is here and time is here. So we're going to do the first one first. So 2000 to 2002. Going to do those two on top. Comes out to negative 0.15. That makes sense because it was going down. And then, so the answer of the passports for this one's going to be 0.3 million difference. So change in quantity over change in time again. So now we're taking the second one. This is the one that went up quite steeply. So that one's going to go up 0.9. So that means it went up 1.9 million, or a change of 900,000 per year over that 2-year period. So explain the meaning of these. So there was average annual drop of 150,000, and there was an average increase of 900,000 for the second two. How are the rates shown differently on the graph? Well, one goes down, one goes up. You know, the first rate is negative, the second rate is positive, so it goes downward and then upward, summarizing that. All right, let's try a few of these. Go. All right, the graph here shows an airplane going up. Find the change from the first one and the second one. So I need to do from here to here, and then from here to here. So I have change in rise over run, so change in departure over year. So I'm going to take 2 is going to be 8.1 minus 6.9 over, looks like 95 minus 90. 8.1, I think that's 1.2 over 5. So if we divide that out, 1.2 divided by 5 comes out to 0.75. Don't think that's right. Calculator error. After I use clear, 0.24. There we go. That looks closer to something that's over here. All right, to find the other one, it's going to be 9 minus 8.1 over 5. That's going to come up to 0.9 over 5. Divide that out, it's going to come to 1.18. Convert that into millions, that would be D, 240 over 180. Or 240 per year and then 180 per year. All right, explain the meaning of that slope for each case. Not really difficult here. For 95, it's going to go up 240 flights. For 95 to 2000, it's going to go up 180. Seems to be the most obvious one because it's, you know, explaining what, you know, from this time to this time and this time to this time. Fairly simple. Hopefully that makes sense to you guys. Number 3. How are the rates of the graph change shown in the graph? Well, again, you're just looking at here. They're going up and then going up. So the vertical change for 95, there's different y values. The vertical change is negative. That one's not negative and positive. There's no difference shown. There really isn't any difference shown in the graph, but maybe a tiny bit, but not much. You know, it's just technically, I guess they want A. I mean, you'd have to really zoom in on this to see it. This is slightly more up and that's slightly more down. All right, positive slope. Find the slope that goes through the line of these 2 points. So we're going to actually label them out, x1, y1, x2, y2. Another way to probably check this would be check the y values. Whichever one's bigger is probably, or whichever one's, you know, later is probably the one that you would want to use for y2. So we're going to put a rise over run. I'm going to insert those in with substitution, and then I'm going to do the math on them. Comes out to 3 over 8. So that would be my slope is 3 over 8. All right, you try. Go. Okay, going quick here. So I'm going to call this x1, x2. I'm going to call this x1, y1, x2, y2. And I'm going to put that in the formula. y2 minus y1 over x2 minus x1. So I'm going to call this x1 is 4 minus 7 over 5 minus, oops, I did that backwards. Do y first. So y is 5 minus 6 over 4 minus 7. That comes out to -1 and -3. And those cancel each other out. Comes out to 1/3. All right, a negative slope. Find the slope that flows through these. So we're going to use the same formula, same concept. We're going to label them out, x1, y1, x2, y2. We're going to use our formula. We're going to substitute them in. We're going to do some math here. So it comes out to -4 over 1 or -4. Same concept here. Go. All right, so we're going to call it x1, y1, x2, y2. And I'm just going to do it a little quicker here. -7 minus a minus 5 over x2 is -2 minus a -3. So that's going to convert to -7 plus 5 over -2 plus 3. So that's going to come out to -2 over 1 over a positive 1. So that's going to convert to -2. Moving on. All right, zero slope. Remember, this is the one if you're asleep, you're at 0. Find the slope that passes through this line. So, same concept, x1, y1, x2, y2. Use my formula. We're going to substitute in. So we put in this 4, that 4, put that 4 here, and that 3 here. Comes out to 0 over 7 or 0. That would be a slope of 0. All right, give this a shot. Go. Okay, going quick here. So x1, y1, x2, y2, -1 minus a minus 1 over x2 is 5 minus a minus 3. Those two come out to -1 plus 1. 5 plus 3 comes out to 0 over 8. That would be a slope of 0. Find the slope that passes through this one. Same basic concept, label them. Use my formula. Punch it in there. When the bottom one on the bottom comes out to 0, the denominator comes out to 0, it becomes an undefined slope. Slope is undefined. Okay, I'm just going to go here so we can get this one done quickly. And -3 over here. So we're going to go x1, y1, x2, y2, -3 minus a minus 1 over, that's a terrible 3, over x2 and x1 minus x1 will come out to -3 plus 1 over 0. Wrong, undefined, moving on. All right, coordinates given the slope. So find the value of r so that a line passes through these points and has a slope of -1. So we're trying to find this r. Point here, find this one with this slope. So to come up with this, we first need to use the slope formula. So we're actually going to use the -1 over 2, and then we know that they're going to turn to this. So now we're using ratios that we used last time. From here, we're going to cross multiply. Oh, sorry, subtract. We're going to simplify that first. Subtract, cross multiply. Now so you can see it, cross multiply from here. Now we're going to distribute. So they distribute it over like this. Gets rid of that 1. From here, we're going to subtract, or we're going to add 6 to both sides. And then that's going to come, those will cancel each other out. R equals 4. Pause this, give it a shot. All right, so first I'm going to label it out. X1, Y1, X2. Oh man, careful, this is negative here. I'm going to put it over here too. Just Y2, that was a terrible slide. and a slope of this. So I know that slope equals y2 minus y1 over x2 minus x1. So my slope is going to be negative, I guess I can go down -5 over 8 equals, we're going to go y2 is -1 minus 4 over x2 is 3 minus p. Okay, we're going to simplify that top one there. So -1 minus 4 is going to be -5. So I keep this negative. I'm going to go this way for just a second. So I'm going to go -5/8 equals -5 over, it's like 3 minus p. I'm going to cross multiply. Cross products is what they like to call it. So it's going to be 5 and then 3 minus p equals -5 times 8. So -5 times -8. Ooh, yes. And that'll be a -5 there. Distribute. So that's going to go to 40. Distribute is going to be 15 minus or plus 5p. Because negative and negative makes positive. And there I'm going to, that's 40. I'm not doing good on drawings today. Minus 15. Minus 15. It's going to come out to 25. And that's going to be 5p. Divide those into there. Comes p equals 5 is what I get. See if that's right with the negative. Oh, it should have been negative. My bad. So if that one was positive, that'll turn this to negative, and that'll add up. Then these would have been negative here. Yep, there's where I messed up. -5 should have been -15, and that would have added, would have gone to 25. There we go. Moving on.